got to nowadays, and the positives and negatives about the whole thing, or some of the positive and negatives. So we're talking about remote internet mediated laboratory, or I call it RTMLEs, remote internet mediated laboratory experiments. Basically, it's a way of using the internet to do experiments. So, why do we do experiments? Well, I had a search on last week, or on the weekend, to say why do we do them. We do them for various reasons, and this is what I found by Ernst in 1983, which was around the time when I started my career, and about what we're trying to do with experiments. And I'm pretty sure if I asked you what the three were, you wouldn't get what the three are. It's quite an interesting outcome. He said the first thing was we want students to become experimenters, which we don't really do with our students now. We use labs for some reason. Another one was they can be for developing new and existing matter, or learning techniques. And the other one is getting some understanding of the real world. I guess we also do experiments to try and get hands-on experience, practical examples, and we do them because everyone learns differently. No one learns the same, so some people like experiments, some don't. So there's an experiment we did 2 weeks ago. This happens to be on the broadboard on the Pimpama, and we've got students on the water doing field measurements. They're doing hands-on stuff, trying to learn something. Do they learn anything? Good question. We have to assess it. In this case, not really assess it, they're just doing some measurements in the water, getting a bit of experience, having a bit of fun. So for this particular class, the idea was to give the students exposure to marine science and to gain some practical knowledge, but it's such a small amount of knowledge they probably don't learn much. But it was to get them on the water, get excited about marine science. So I'm going to take you back a bit. Imagine 1994. Yes, you were all born then, I think. Yeah. And I thought, what happened? I'm doing both here. What happened in 1994, like the timeline of our lives? And these 3 movies came out in 1994. I didn't realise they're that old now. They're 20-year-old movies. And anybody remember The Lion King? That also came out in 94. The Channel Tunnel opened in 94. Get the high-speed trains. And for the electronics people in the room, really, not one. Netscape browser came out as a common tool for using on the internet. I'm not sure Netscape exists anymore, but it became one of the first browsers we could readily use to talk on the internet or communicate across. What happened in 1994 also, I packed up my bags in Western Australia, moved to Deakin, Victoria, or Geelong, Victoria, went to Deakin University as a young, fresh-faced person. At that time with 2 children, and life went on. And when I got to Deakin, my first job as an academic was to try and teach students in distance mode. At Deakin, many students did not come onto campus. If they did, they didn't do much necessarily anyway. But like all students, we think they don't do much. But that's the way students are. They do a lot of work actually. But in those days, we had programs and subjects. It took me a long time to start saying courses when I first came here. And it's done in distance mode. So we used to get on our computers, I had Pentium 4s, 386s, and type our lecture notes up, send them to an editor who fixed them up for us, and then they got printed out in a printer and sent off to the students. And then for our assignments, they came back in snail mail. So they post their assignments to us, we could mark them and send them off. That's the off-campus students. If you wanted to answer students' questions, then it was either by telephone or by fax. And it's very hard to explain to a student over the phone how to solve Miller's equation or draw a pressure diagram or something like that. You had to try and draw it in front of you and get them to do the same thing. And laboratory class activities at the time were things like sending our students elastic bands, asking them to go and buy a soup container, and looking at how the elastic bands expanded over time with different weights. Or you had to bring students on campus to do the experiments, which caused problems at the time because it was quite costly to come on campus. So what happened next was there was a meeting held with Professor Laurie Baker, who was the head of engineering at the time, and a guy named Tim Martin. And we sat down and Laurie asked us, Tim and myself, a very simple question. Can we use the internet to do experiments? And Tim and myself looked at each other and said yes. We had no idea what we were doing. Not the foggiest. Well, we view the internet when you transmit things around. That's all we knew about it. So we thought, okay, thanks Laurie. He said we'd do it, so we went off and did it. And the thing that happened, actually the week before that meeting, there was an article that came out in the magazine, and it was called about the Mercury project. So in 1994, 93 they probably started, 94 you could actually log on to a computer, an IBM robot. This computer controlled an IBM robot. It could blast a bit of air out of the nozzle of the robot, and you could move it around and expose different things in sand. It allowed anybody to log onto a system anywhere in the world who had computer access at the time, blow the sand and do something. So you could actually control an instrument internationally. And that was the first reported case that I know of that's publicly available. This is publicly available. You could do that. There may be other things around, but that was the first publicly available thing. So there was your JPEG image of the nozzle blowing the sand. To get that image, well, we had to log on first and try and get onto the system, which was good for a university person because most people didn't have the internet at home. So you get onto it, and that image took around 1-2 minutes to download. And it's a JPEG, so it's a very small image, took a long time to download. So Tim and myself went, okay, let's do this. It's nice to be really ignorant of what you could or couldn't do at the time. So what we did is we then started a project called the Flow Project. And what we basically did is we thought, what can we do? How do we do this experiment over the internet so students can log onto a system, do an experiment, write a report, get assessed on it, and hopefully learn something? So in 1985, so we got funding to do this through what they call the Court Grant, Commission for Advancing University Teaching. It was a nationally competitive grant. We got money from the Apple University Development Fund at the time to buy a camera and a computer. The computer then was around $4,000 for the computer to control. The system was another $2,000. The camera was $1,000. It was quite an expensive activity back 20 years ago, but we did it. So what I then did, I gave a talk in 1995, A squared, E squared. Can't find the talk. My system is so out of date now, I could not locate my original talk. So I've got one from 1996. So this is version 2 of our project. And version 2 went like this. So John Florence was a master's student who came on board the project. John knew a little bit about programming. Not a lot, but we learned a fair deal. We learned a lot about it. So this is original talk. So anybody who was there in 1996 at the A squared, E squared conference, here it is again. Was anybody there? No, okay. All right, so what we said, the project aims were we wanted to develop a system which was readily accessible to the students, was flexible, educational, relevant and cost effective. Cost effective is a relative term because it's cost effective for the student more than us. Previously we had sent things to students at home. We'd use videos. This is VHS tapes, not 8-track tapes. We had computer learning packages where those students could use what a micrometer was, done as a simulation. We could bring it on the campus for residential schools. We also got them to workplace activities. They still do it nowadays. So the new method was this. We're going to get a student to log onto a site, do an experiment remotely, and write the report on it and get assessed. So this was our very simple experiment, flow over a weir. So we have a reservoir, we have a pump connected to that, pumps water around into a tank, the water fills up behind this weir structure. Once it gets high enough, it flows over the weir and it cycles around through the system, and you can calculate the coefficients for the weir based on the flow rate, and that's what we want the students to do. We want to ask the students, could you work out the relationship between the height of water over the weir and the speed of the pump? That was the experiment. That was the image that the camera took, a nice big VHS camera with a JPEG output. Not quite the same as this thing. That was the whole setup. So there's the camera, there's the speed controller, it was a 3-phase motor. The computer controller had a very, very expensive ADD card in it. And we got in trouble once because someone actually broke in the building and stole it. And we had to replace the computer and controller card as well. And so the student could hook up to the internet through this system and go on and do the experiment. So the interface is HTML. It's also blasé now, actually. It was quite new at the time. We ran the CGIC programs and it was mouse and keyboard operated. Glad you're here, Mark. I'll show you why later.
Sorry,
So
just finished teaching, sorry.
that was our AGSE web page. The student could log onto this web page and connect up to the experiment, tell us what the experiment was about, and gave you some information about it. And this was our control interface, where the student would type in a number for the speed of the camera, or the speed of the pump, sorry, and that was the camera image that would come up here. So they entered a speed, in this case was 25 hertz. We didn't actually have a flow rate, we just had a frequency at this stage. And they entered it, it then asked for a password and username. We had to do that to make sure not everyone was trying to control the camera at once, or the pump at once. And once they entered the speed, it registered the speed was set to 25 hertz. Then the fun started. Then we tried to download an image. And the image would look like this. So that, over a telephone line at 256k, would take 2 to 5 minutes. That's the speed we were looking at the time. So it was like a snapshot only. And it worked. We could have students go and do this experiment from anywhere in the world.
Is it the real one or just simulate?
This is real. The first question, in 1995, the very first talk I gave, the very first question I had was by a former colleague of mine. He said, why don't you just use captured pictures? Because we wanted to be real time. We wanted things to go wrong. It wasn't nice someone stole our computer, but at least it went wrong. I was happy if a cockroach flied over the top and things like that. Because we were trying to simulate real stuff. So this was a real picture taken real time with the camera. So we tried it on students. We had 27 students come in and do it, split them into 3 groups, and see how they went. And basically watched them by ethics approval, all that sort of stuff we did. And we found, when we assessed the students' reports, there was no difference between the student doing the experiment in front of the unit to the student who did the experiment remotely. There was no difference in the report quality. There was a difference with the age of the student. The mature age students did a better report than non-mature students. Not the immature students, but the not so mature ones. That was about the only difference we found. And the students gave comments. We looked at what the students thought. They thought it was stimulating. The transmitted image lacked clarity, not surprising, the JPEG image of those days. A bit different to the high definition videos nowadays. They felt they learned something, but they wanted to be hands-on. What we saw was the typical thing we see in laboratories still. If there's 2 students, one does most of the work, one watches. If there's 3 students, then one doesn't work, the other 2 watch. 20 students, one doesn't work, 19 watch. So it doesn't change. It didn't actually change much what we were seeing. Now this originally had the word conclusion on it, but you don't put conclusion up during slides, so I did change the title word. But that was the conclusions for the work. It worked. We could actually get students to do experiments from anywhere in the world at a time and space or place convenient to them. So it definitely satisfied our objectives. What we realised also is it doesn't satisfy all the objectives. One is you don't get the hands-on experience, you don't get that touchy-feely thing of what the experiment actually does. You can see it, but you can't really touch it. And that's, as we'll see later on, still the problem today. These are the restrictions we found at the time. Communication bandwidth, student equity, we had to make sure we were being fair to the students, so online was the same as offline. They did lack hands-off on nature, and the initial setup cost was quite high. But it worked. So, if you want to quote this work, please quote the first one. That's the first ever publication on internet mediated laboratory experiments. So So please quote the first one. And that was the second one this talk was based on, that I presented in 1996. So what the next phase was, picked up my family, 4 kids, one on the way, came to Queensland. And after a few years we thought we might try to do it a bit more advanced, so we gave it a bit more of a go. And that is, in a normal laboratory experiment, you have the students, you have the experiment, and you have a demonstrator, and they interact with each other. Internet experiments don't have the demonstrator built into that loop. So it's just that exchange only, this one doesn't exist. So you have to design a very good web interface to act like a demonstrator. So we thought, okay, let's try and do this on the internet, and I'll go past that one. So we have the off-site students, here's the experiment, we want the demonstrator to interact with the experiment, we want the demonstrator to interact with the students, and we have also the on-site students. So we had this sort of loop system made. And there's a colleague in the room here who was actually part of that original experiment.
What are you looking at me for?
And for those the computer people, this was our lovely picture we drew. Don't go, Mark.
I'm not getting more food.
And
a picture of him?
just for those computer people. So there was the experiment, the concrete beam cracking one, which I believe is still done today, isn't it?
Yeah.
Still crack the concrete beam? Okay, so you know the diagram, here's the beam, put a force on it, students climb underneath, I think it's reasonably safe still, and look at the crack pattern. So there's a bunch of students, and you might recognise this one here. I believe that's you, Mark.
I can't see it.
That's all right.
No, it's got too much hair.
That's Mark there. And there's a few other students you might recognise from 2002, our concrete students. That was there, and the same thing happens then as we saw in the internet experiment. 1 or 2 do all the work, the rest stand around the room like they're doing nothing. If there's one thing we need to do in experiments is get the students interacting with them, not just stand around the room. Then the students, in this case we had the computer set up in another room. They could look at the demonstrator, this was a demonstrator actually, it wasn't a demonstrator, but we got the student to be the demonstrator, to interact with the students in the other room. We still had bandwidth issues trying to transmit sound, so a lot of it was typed, if you remember, typed words. But the student could then interact with the experiment from another room. And that was the other room. There's Mark walking in the other room. That is you.
Why have you got so many pictures of me?
And that's Christy, one of our PhD students. So they could actually see the experiment there in the other room.
Student worship.
So we tried this. It did work. It does. At the time, it certainly had issues with trying to get the bandwidth across between. This is one room to the next. That's the concrete lab, and that's where the technicians sit now. It was hard to get even the bandwidth then to transmit the sound and video across in a good speed. But it did work. Same things were resulted. The students thought it was groovy. You needs digital links for those concrete cracking people. We still need digital links on the concrete experiments. And was it better outside or inside? If you remember, Mark. Obviously better seeing the experiment, I think, than it was doing it remotely. But at least remotely gave you a chance to do something. So we sort of stopped there a bit. For various reasons, we didn't progress it much further. So in 2011, people still continue with it. They still don't quote my paper enough, that's unfortunate. But they still said the advantages, disadvantages. This is a 2011 paper, when they're saying disadvantages. One of the things that came up, because these things became a lot more prevalent, institutions basically developed their own systems. And it becomes hard to integrate one system to the next and make them work. And you still have good internet connections being the same thing. It's 25 months, not half past. So the positive was still there. To use collaborative tasks, they can still do things. They can still interact with the experiment. But the real question was still, and the question still remains with me, is, and Graham would probably testify, is if you're going to do a laboratory experiment, what's the point of it? And all the work we did originally for the first 5 years, the point was basically to get the students to do something and assess a report. We weren't actually trying to develop their skills very much except report writing. And that's something about internet experiments. You don't actually do, you can do a bit of theory development and report writing development, you don't get the hands-on stuff. But having seen some work in the laboratory recently, we still don't see there's not a lot of hands-on stuff going on. Students stand around, we have 5, 6 students doing an experiment, one does all the work, the rest 5 or 6 just watch on. So I think it's something we need to address in the future. So, I will show you this little, where are we now? Well, if this works, I don't even know if there's sound on this actually. Let me try this. Right now. This is what we're up to nowadays. There's your internet experiment. Doesn't look much different from what we did. This is 20 years later. And you can control a pump. What we did 20 years ago. And you can vary the speed of the pump, but now you can control the camera, look at the flow rate, and you can pan it around. This is all done through LabVIEW software. It's called LabShare. Now LabShare is a consortium of universities which got together to produce a series of experiments that you can do to help educate students of some form. I'm still pretty convinced the main thing they'll learn is report right and a bit of theory back up. So when you turn the pump on, it starts to spin the wheel, and you'll get the lights coming on when the wheel gets fast enough in the house. There's the light coming on, you speed it up to get more lights on. Like dance to music. So this one is actually run out of UTS, I think. So we're the main players in this now. They're like the main players in these experiments. You do structural experiments, you do robot controlled experiments, trusses, things like that. Nearly done. That's one thing you have to have organised for these experiments, and when students can actually do them. In the Mercury project, you put your name down for the next one coming up. We, in our experiments, do have our own databases, so students can log in, book a time, and we let them in on a certain time. Took a lot of programming in those days. And you get your data, you do things. You do a simulation if you want. Get a CD for a simulation on it. The idea is to make it real time, a bit more interactive. And if Griffith wants to get involved in this, it costs $50,000 to get involved in it. They did approach us a few years ago to get involved, and at the time it wasn't really cost effective. So that's where it's got to nowadays. Lots of experiments around the place. Lots of activities you can do, and so if you wanted to get involved, you can. If the fluid mechanics, structural interactions, trusses, you can do the experiments on that. Interesting enough that when I visited these guys at the A²E² conference a few years ago at UTS, and one of the comments they made, which was very interesting, is that students still were shown the lab. But they actually walked in and looked at the truss experiment, they could look at the 3D nature of it and touch it if they wanted to. And then they do the experiment later on. It's still not completely internet controllable only. The students still got most out of it by going in and looking at the experiment and trying it out. We just don't have that perception of real world versus fake world, which is not a bad thing. So in summary, a quick talk, half an hour, 25 minutes. Laboratory experiments are useful for engineering. I think we certainly have to think of what we want from them and where we want to take them, how much we want to use them for, what sort of educational purposes they have. It's a bit sad I find it a bit sad, actually. I like experiments. I'm a hands-on person. When you go into the laboratory and you see all these students sitting around not doing anything, it was a 3-hour lab or 2 or 3-hour lab class. Even on the boat we had last week or 2 weeks ago, a couple of students were interacting with it because we just can't afford to take students 4 or 5 at a time anymore. In their activity, they looked at they were actually counting fish. We had 3 fish to count. So you needed 1 student to do it really, and look at the seaweed and everything else. There's more one way to achieve what you want, and that's why the internet experiments. Former head of school said, "What are we doing it for? It's wasting our time that the students don't touch." Well, it's not meant to replace. We're not trying to replace hands-on experiments. We're trying to. It's like an adjunct. It's an additional learning tool. And as I said, the main thing we found out, these were good experiments. The students could get some data from it. They could use real-time operation. They could try things, and they could write a report on it. That's what it was aimed at. It was basically report writing. We can do a lot with current technologies. I think one thing that will go forward in the future, I'm not mentioning 3D printers. Sorry, I mentioned it. It's not 3D printing. It's more to do with making look at the 3D image of the whole thing. Can you move around the whole device and see how it's shaped and all that sort of thing, or maybe tactile one day. Interestingly enough, speaking of 3D printers, the next version of this project at Deakin aimed to actually run a CNC machine on the internet, so the student could actually put an item in there and actually build it in real time. I don't think it ever worked though. A bit too advanced at the time. That was the next version of the project. Again, thanks to these guys, Laurie Baker, KK Wong and John Florence, and Tim Martin, sorry, on there as well. Who basically, these are the ignorama with me who tried to do something we didn't know we couldn't do, and we still did it. So that was quite a good thing. So that's my very short talk. Not doing too much.
Thanks, Charles. It was really interesting. We have any questions? Let's start with questions from the floor. Anybody wants to ask?